children, a very good morning to all of you. Today, let us start a new chapter, that is chapter 4, Atoms and Molecules. But before we go ahead into this chapter, let us quickly just recall what all we learned under chemistry this year. You see, in the first lesson, we learned about matter in our surroundings. That means matter, what matter is composed of, different states, interconversion, etc. In the chapter 2, we just went little deeper, differentiating different kinds of matter, like pure substances and mixtures. We just saw many examples and different ways of separating these different substances, like purifying them and all. In the third chapter, we went even more deeper. That is, we learnt about molecules in particular, like elements and compounds. So what matter is actually composed of? It is actually composed of molecules like elements or compounds. We learnt about valencies and all that, right? So now we learned about the mole concept. That's very important in the third chapter. And now we know we are going much deeper into the subject of chemistry. So in this chapter, we will be knowing about atoms and molecules. So what are molecules composed of? So all the elements and the compounds are actually composed of very tiny, indivisible form of matter, that is nothing but atoms. So now we know that atom is not the finest or the simplest particle, but atom also contains some particles in it. So we are going deeper inside the atoms now. We will be learning in this chapter what are the various subatomic particles, how they are discovered by different scientists, and we'll be learning about the atomic models, how different scientists put forth their view regarding an atom, structure of atom, how does an atom appear, okay, how they combine with each other and all we learned in the third chapter. But what is present inside an atom, we will be learning in this chapter, children. So now we know that the atom actually is composed of, it contains inside some subatomic particles like electrons, protons and neutrons. And not simply that, simply we don't know about all these things. Behind this, there is like a restless work and tremendous research and experiments that were undertaken by different scientists, and now we know that atoms do contain some subatomic particles which are nothing but electrons, protons and neutrons, children. We know now that electrons are negatively charged subatomic particles which are present outside the nucleus. Basically, an atom contains a nucleus and then external part also. So we have electrons revolving around the nucleus, just how the planets revolve around the sun. There is one comparison actually. So they will be revolving, and what is it? They have a negative charge. We all know this, and the mass is very, very negligible. Very, very negligible mass they have. Protons and neutrons together, they are called as nucleons because they are present in nucleus, that is the center of the atom. So protons are the positively charged subatomic particles, and neutrons are the neutral, that means they don't have any charge on them. So these three, protons and neutrons together, protons have a mass of 1U and neutron also have a mass of 1U. So if an atom contains one proton and one neutron, its atomic mass will be 2 neutrons. Two atomic mass units, unified mass. Okay, so this is what is we'll be learning more about it in the coming topics actually, one by one. So as I told you that there are so many scientists, who have worked a lot in order to elucidate, or in order to bring up, put forth the structure of atom, how atom looks like actually, because as you can see that they are so minute. You can understand by this that one pinhead contains 6.0 into 10 to the power of 19 atoms. Can you imagine how small these atoms are now? That means one pinhead, that ball pin will be there, no? That pinhead will contain, after 6 you have to go on putting 19 zeros. So those many atoms will be present on one pinhead. So you can understand, knowing or understanding or elucidating the structure of such a small particle it involves like it's really very, very difficult. So these scientists, they have worked tirelessly actually with the proof they need to put forth their theory. It's not just that hypothesis, something they say and there is no one to believe them. No one will believe them. They have to actually give some support, or what you call a proof or an evidence actually along with their theory, such that then only their theory will be, you know, accepted. So many scientists actually we will be learning in the coming classes, different scientists and their experiments, how they have actually proved the structure of atoms we will be learning. For today, let us see the J.J. Thomson model, children. So Thomson, as you know, that he is the one who had discovered electrons. So he is the one who has started a new stream of science, which is nothing but, you know, electricity, electronics, right? So electricity and electronics, they all they bloomed only after the discovery of electrons by J.J. Thomson. So he has actually proposed a model. He has proposed a model that he said that atom is like a Christmas pudding, you know, the nut pudding actually, in which it is actually a sphere, a 3D sphere, okay, it is a 3D sphere which is positively charged, a positive 3D sphere, and in that you can see electrons embedded as the raisins. He compared those electrons with the raisins and the nuts which are there on the Christmas pudding, or a watermelon. If you take a watermelon, the red colored flesh part, you know, the red flesh or the pulp, or whatever you say, the flesh of the watermelon is considered as the positive 3D sphere, where the protons and neutrons are present. Protons are present actually, positive sphere. And then there are how seeds are just scattered all around in the watermelon. In the similar manner, the negatively charged electrons also are just scattered in this positively sphered atom, he said. So that is the reason, and he also said that the number of electrons will be equal to the number of the positive charges will be equal to the negative. Magnitude of positive charges will be equal to the magnitude of negative charges. That's the reason why the atom is neutral, he said. So he got some points actually. This was one of the first models to describe the structure of atoms, and he has some logic also here. Why is atom neutral, he said? Because the positive charges and the negative charges are equal in number, he said. So that is why the atom is neutral, he said. He proposed this, but later on, as you know, the studies advanced, you know, different scientists, they worked more and they could actually find some drawbacks, many drawbacks regarding this model, but nevertheless this was the beginning of, you know, it actually triggered many other scientists. Actually they got interested to know the structure of atom, actually of that indivisible part of the matter. So many scientists did research, and now at present we know the more realistic structure of atom. So it all started this way. This was the first model, and second we'll be learning about the Rutherford experiment and his, you know, concept of atom. So in the next class we'll be learning about the Rutherford's alpha ray scattering experiment, and what are all the postulates that he did, and all that we'll be seeing. There are several other scientists like Goldstein, the Bohr, all these, these scientists, they really helped understand the structure of atom in a better manner. So how it all advanced, how it all happened, we'll be learning one by one. Okay.